Good morning. By now you would have gone through the concept of increasing and decreasing functions and would have understood it properly. Okay, and let me just do a quick recap that a function fx is increasing in any interval a b if and only if f dash x is greater than 0, fx is decreasing in that interval if and only if f dash x is less than 0, and fx is a constant function in the interval ab if and only if f dash x is equal to 0. Now with this concept, let's start with polynomial functions. Okay, now suppose we are given, let's continue with the exercise 6.2. Let's start with a very simple question, that is question number 6, first part. Okay, now it says that fx equal to x square plus 2x minus 5. We need to check the intervals in which this function is increasing and strictly decreasing. As we all know, for a function to be strictly increasing, it should be strictly greater than 0, and here f dash x should be strictly less than 0. So we should actually write, we check for all points it is strictly increasing and strictly decreasing if the conditions are satisfied for all x belonging to the open interval, for all x belonging to the open interval here. Now if it is greater than or equal to, it would be increasing. If it is less than or equal to, it will be decreasing. So that we will consider later. Most of the questions, they will ask you to find the intervals in which it is strictly increasing and strictly decreasing. Now the function is fx equal to this. So first of all, we will find differentiating with respect to x, we get f dash x equal to 2x plus 2. Now we have to put it to 0 to divide the real numbers into intervals. Okay. Now so if you, and for that we equate it to 0, because f dash x equal to 0 means at that point the function is constant. This gives you x equal to minus 1. So the real lines can be divided into two intervals. One is on the left of x equal to minus 1 and one is on the right of x equal to minus 1. So the two intervals are minus infinity to minus 1 and minus 1 to infinity. Now here if you notice, we will make use of open brackets because the question says strictly increasing and strictly decreasing. If we include minus 1, then the function, whatever it is, it will be either increasing or decreasing, because at x equal to minus 1 the function is a constant because the derivative is 0. So that's why we don't make use of square brackets here, we use small brackets instead. And minus infinity plus infinity in any case are always clubbed with a small bracket. So the two intervals which we get here are minus infinity to minus 1 and minus 1 to infinity. Now the best way of doing the questions is you make a table so that it becomes very clear as to what you are doing. So first you write intervals then you write f dash x, and then you write nature of the function. Okay. Now here the two intervals are minus infinity to minus 1 and the other one is minus 1 to infinity. Now the best way of checking with, now here one more thing, as we have already studied in the previous video, that a function, it will become it will maintain its nature in one particular interval, means it will go from increasing to decreasing and so on. If it's a continuous function, it will be somewhat like this. So if you can see, at the point where the function is changing the direction, the derivative is 0. Okay, so it goes from increasing to decreasing, then again increasing, and then again decreasing. Between 2 points where the function, the derivative is parallel to the x axis, here f dash x is equal to 0, f dash x is equal to 0. So between two consecutive points of change in direction, the function maintains its nature, that it between in this interval it is increasing, then between these 2 points it will always be decreasing, and then again increasing, and then again decreasing. So here f dash x is greater than 0, here f dash x is less than 0, and so on. And so what we see is, if it is f dash x is greater than 0 at any point in this interval, all points of this interval will show the same property, that is f dash x will be greater than 0. The same way over here. So in order to prove that a function is increasing or decreasing, what we do is we take any one point in the given interval. So whatever property that point shows, all the points in that interval will show that property, and let's see how we do this. So now here f dash x is equal to, we have 2 times x plus 1. Okay. Now here let's take any value x equal to any value of x lying in this interval, let's say minus 2. So when you substitute here minus 2, what do we get? It is equal to 2 into minus 2 plus 1, which is negative. Negative means less than 0, and so the nature of the function, the f dash x is less than 0. It implies it is decreasing in this interval, and we also sometimes use the downward pointing arrow to show decreasing. Now here, and again one more thing, if you just observe in any continuous function, it will be alternately increasing or decreasing. So the moment you get here decreasing, and if you have done the workout properly, the working properly, so it means the next interval you should expect increasing nature. Okay, so let's check it. So here we choose a point lying in the interval minus 1 to, so let's take a easy number, which is 0. F dash x would be 2 into 0 plus 1, which is positive, greater than 0. So f dash x is greater than 0, which implies increasing, and we show an upward pointing arrow. So thus fx is strictly decreasing in minus infinity to minus 1 and strictly increasing in minus 1 to infinity. So this way we can easily do the quadratic functions given to us, and when you differentiate you will get only one point at which the derivative would be 0, and accordingly 2 intervals which you can discuss. Now suppose you come across a cubic expression. Let's take another example. Let's take up question number 5. So if you come across a cubic expression, and we need to check whether the intervals in which it is increasing or decreasing. So fx is equal to 2x cube minus 3x square minus 36x plus 7. 2x cube minus 3x square minus 36x plus 7. We need to check the intervals in which it is increasing or decreasing. Okay. Now here, so what we do is, you will first find the derivative. So f dash x is 6x square minus 6x minus 36. Okay, we equate it to 0, and then what we get is, we don't remove any of the constant, though usually when you solve an equation we can remove the constant, but we don't remove the constant, we keep it as it is. So f dash x equal to 6 times, we get x square minus x minus 6 equal to 0. When you factorize it, it becomes x square minus 3x plus 2x minus 6 equal to 0, which gives us x minus 3 and x plus 2 as the two factors. So f dash x is this. When you equate it to 0, this gives us x equal to minus 2 and x equal to 3, and thus the real line is divided at 2 points into how many intervals now? 1 on the left of x less than minus 2, x lying between minus 2 and 3, and x greater than 3. So it is divided into 3 intervals. Okay, and thus the intervals are minus infinity to minus 2, and here if you just notice, again we are using only small brackets because we want to exclude out the points at which the derivative is 0, because that makes it makes the function constant at those points. Now this, then the next one is from minus 2 to minus 3, excluding both, and then the last one is 3 to infinity, again excluding both. So now to analyze it, we again make that table, intervals, then we write f dash x equal to 6x minus 3 x plus 2, and then we write nature of fx. Then again we first make a list of all the intervals, minus infinity to minus 2, minus 2 to 3, and 3 to infinity. Now in order to test, again as we have seen in the previous question, we will just check at any one point lying in that interval, whatever property the function satisfies at that point, that property, all the points lying in this interval will satisfy it. So let's just take x equal to any point lying in this, the easiest would be minus 3. So we get f dash x equal to, now minus 3, this is negative, into this is minus 3 plus 2, which is again negative, which is positive, greater than 0, f dash x greater than 0, which gives us increasing. Now here we choose a point, so let's take the easiest one, which is 0, f dash x equal to, this is 0, so negative. Here when you put 0, you get positive, it gives you a negative number, less than 0, f dash x less than 0, which implies decreasing, and we show a downward arrow. Next one is a point, let's choose 4, f dash x would be, now here when you put 4, this would be positive, when you put 4, this is also positive, this gives you positive, greater than 0, f dash x is greater than 0, which gives us increasing. Now as you can clearly see, it is alternately increasing, decreasing, and then increasing. So thus fx is, now here strictly increasing in, there are two intervals, so you will just simply write union of these two, means either this or both. Okay, so you write union 3 infinity, and fx is strictly decreasing in, then we write only one interval, that is -2, 3. But if you just notice, the question asks us increasing and decreasing. So how does the answer change? Also fx is increasing in. Now how do we show increasing? If you include this point at which the derivative is 0 and this point, it becomes an increasing function. So how do we report the answer? You put a closed bracket here, union, and here also a closed bracket, and we get this. And fx is decreasing in. You will use square brackets in both the cases, so it's a closed interval, this. Okay. So now one more question which is slightly different than this, but another very important one, that is question number 6. Let's take B part, okay, or we can even take the C part. So question number 6, C part. B part is much easier than this, but on the same line, so you can do that on your own. Question number 6, C part, says that fx equal to -2x cube minus 9x square minus 12x plus 1. Though the question looks similar to what we considered just now, but if you observe carefully, the highest power of x is negative, and this is what makes it very important and special. So let's find the derivative first. We get minus 6x square minus 18x minus 12. Let's factorize it. First of all, let's take common. We get x square plus 3 times x plus 2, and when you factorize it, it becomes x square plus 2x plus x plus 2, and this gives us minus 6 x plus 2 into x plus 1. F dash x equal to 0 gives us f dash x equal to minus 6 of x plus 2 into x plus 1 equal to 0, which gives us x equal to minus 1 and or we should write minus 2 first, minus 2 and minus 1. And so if you just see, this is minus 2, minus 1, 0, 1 and so on. One thing is x is less than minus 2 on this side. Another interval is lying between these two. So x lies between minus 2, minus 1, and the next one is x is greater than minus 1, which is this side. And so thus the intervals are minus infinity to minus 2, minus 2 to minus 1 and minus 1 to infinity. Now to check the nature of the function in each of these intervals, we make this table, intervals, then f dash x. Now here be very careful while taking down the value of f dash x, include this constant, this is very important. So minus 6 into x plus 2 into x plus 1, and the last one is the nature of fx. Okay, then we write the 3 intervals. One is minus infinity to minus 2, next is minus 2 to minus 1, next is minus 1 to infinity. Now again we take a point. What do we get? Let's take x equal to minus 3 here. We take x equal to minus 1.5 here, because a point line, we have to find a point lying between these two consecutive numbers, and x equal to, let's take 0 here. So f dash x will be, now one negative sign will be because of this negative, into when x is minus 3, this is also negative, when x is into when x is minus 3, this is also negative. So, in all product of 3 negatives is equal to negative, which is less than 0. So, f dash x is less than 0, it means decreasing. Please note that if you had not taken this into consideration, this sign, the result would have been exactly opposite of what it actually is. So, be very careful in such questions where the highest power of x is negative. You have to include that negative sign also while analyzing. Now, here f dash x would be, when you put one is negative sign already, then here minus 1.2 1.5, so this makes it positive, into here negative, this makes it product of two negatives is positive, which is greater than 0. So, f dash x is greater than 0, it means increasing. And the last case is f dash x is equal to, when you put a 0, first thing is a negative sign, here positive, and the next also positive, and which makes it a negative less than 0. So, f dash x is less than 0, which means decreasing. So, thus fx is, now here we are writing strictly decreasing in union of these two intervals, that is minus infinity minus 2 union minus 1 infinity, and fx is strictly increasing in the middle interval, which is minus 2 to minus 1. Again, you should be aware of this, that if the question was to find the intervals in which it is decreasing and increasing, we would have used here square brackets instead of small brackets. So, with this you just try out the rest of the questions which are similar to these, and then we will again continue later. Thank you.